Hello. Today we're going to discuss 6.5 evaluating definite integrals. We're going to start from some properties of the definite integrals. Property 1. If you integrate the function from a to a, you get 0. We know the definite integral gives the area under the curve. So if you integrate it from a to a itself, that means you're going to get a zero width of the region. So consequently, the area on the curve is 0. Property 2, if we integrate the function from b to a, is just the opposite of the integral from a to b for the same function. And this is because the increment in x, which is dx, changes sign when you integrate it from b to a. Property 3, you can always take out a constant from the integrand. Property 4, if you integrate the sum or difference of two functions from a to b, you can always integrate each function from a to b and then add or subtract them. And property 5, and when you integrate a function from a to b, you can always split it into two, one from a to c and the other from c to b for the same function. That means when you find the area under the curve from a to b, you can always split the area into two, one from a to c and the other from c to b. So all of these properties can be easily understood based on the geometrical interpretation of definite integrals. We discussed the method of substitution for indefinite integrals before. You can always use this method for definite integrals. The only difference is that you need to change the lower and upper limits of integration when you carry out definite integrals for new variables. So let's do an example. Evaluate the integral x squared times 2x cubed minus 1 to the fourth from 0 to 1. This is integral from 0 to 1 in x. And we got a composite function in the integrand, which is 2x cubed minus 1 to the fourth. So we can define the inner function 2x cubed minus 1 to be u. And then take the differential of u, we get a 6x squared dx. If we divide 6 on both sides, we get the x squared dx equals du over 6. And then you find out the lower and upper limits of integration for u, because we're going to carry out the integral over u after change of variable. So when x is equal to 0, u will be 2 times 0 cubed minus 1, which you just plug in 0 for x in u. And you get negative 1. And when x is equal to 1, u is 2 times 1 to the cube minus 1, so you get a 1. So these are the lower and upper limits of integration for u. So the integral can be rewrite as 2x cubed minus 1 to the fourth times x squared dx if you rearrange the order of the terms. And then you replace 2x cubed minus 1 to u to get u to the fourth, and x squared dx to du over 6. And also at the same time, you change the lower and upper limits of integration from negative 1 to 1. And then you take out 1 over 6 from inside, so we get the negative 1 to 1, integrate u to the fourth. And so we got 1 over 5 u to the 5, and multiply 1 over 6, so we got 1 over 30 u to the 5. And then you plug in 1, negative 1 to get 1 over 30, 1 to the 5 minus 1 over 30 times negative 1 to the 5, and we got 1 over 15 for the final answer. Let's talk about the average value function. Suppose f is integrable on the closed interval from a to b, then the average value of f over the interval from a to b is just 1 over b minus a times the integral of f from a to b. Let's do an example. Cell phone ad spending between 2005 which is t equal to 1 in this problem, and the year of 2011, t equal to 7, is given by this function s of t equals 0.86 t to the 0.96. Where s of t is measured in billions of dollars and t is measured in years. So this is the advertising spending between 2005 and 2011. What was the average spending per year on cell phone ads between 2005 and 2011? So we just find the average of this function. So in this problem, A will be 1 and B will be 7. So using the formula for average function, so we got 1 over b minus a times the integral of s from a to b. So we got 1 over 7 minus 1 times the integral of 0.86 t to the 0.96, integral from 1 to 7. So we can simplify this a little bit by taking out the 0.86 and then integrate t to the 0.96 from 1 to 7. And we got a t to the 1.96 over 1.96. Now plug in 7 and 1 for t and subtract. So we got the 0.86 over 6 times 1.96 times 7 to the 1.96 minus 1 to the 1.96. After the computation, we got the $3.24 billion. So this is the average spending in advertisement in each year between 2005 and 2011. So this is the end of today.